Sometimes it's convenient to solve for a variable in terms of other variables. This is particularly good for formulas so that you don't have to keep doing the same math steps over and over again. So let's say we have a formula or an equation like this. We have k equals 9r minus s. So if you notice, we have a lot of different variables here. So we're going to want to solve for r. Okay, so I want to get r by itself eventually, but the first thing I do is I look and I notice that I have a term that contains my r. So I need to somehow isolate that first. So let's take a look. We have k equals 9r minus s. And I'm going to try to get my 9r by itself. So I look and I think, well, how do I get rid of this minus s over here? Well, since I'm subtracting an s from the 9r, I'm simply going to add that s. And I'll add the s over on both sides so as to not upset the balance of the equation. So I get k plus s on one side, this side cancels, equals 9r. Now remember, the last thing I do with any to solve for any variable is divide by the coefficient. The coefficient in some of these literal equations could be a variable or a number. And in this case, I want to get r by itself. Then I ask myself, well, what am I doing to that r? And this is a multiplication. I'm multiplying it by 9. So I need to divide it by 9. So I need to divide both sides by 9. My 9's cancel, right? They become 1. So I simply get r equals k plus s over 9. I treat every other letter, every other variable that I'm not interested in, as though it were simply a number. So let's try another one. Here we're given the equation negative 3 equals negative 18r plus 6s. Here I'm asked to solve for s. Right? So I look for the term that contains my variable that I'm interested in isolating, and I see that it's 6s. So I somehow need to get rid of this, right? I need to get rid of the negative 18r. So because it's a negative 18r, I'm going to add 18r because that'll make it 0. And over here I'm going to add 18r as well on the other side of the equal sign, right? This is my equal sign. So negative 18r plus 18r goes away. I get 0, and I'm left with 6s on this side. These two aren't like terms, so I'm just going to rewrite it 18r and minus 3. You can't simplify that any on this side of the equation, so I'll just leave it at that. Then what I need to do is I want to again isolate my s. So what am I doing to my s? I'm multiplying it by 6. So to get rid of it, or to make the coefficient 1, I'm going to divide by the coefficient, divide by 6. So I get 1s. And over here I need to divide both sides by 6. So I simply have s equals 8r minus 3 over 6. Now the interesting thing about this problem is we're not actually quite done. Because if I look at my numerator, I notice that they have a common factor, right? I can take a look, I see that 3 actually goes into both 18r and 3. So I'm going to factor out a 3, and I'm left with 6r minus 1 divided by 6, which is 2 times 3, right? So my 3's can cancel, and I have 6r minus 1 all over 2 equals s. Another way you could look at this is from this step here where I had 18r minus 3 all over 6 equals s. This 6 needs to go with each one of these terms on top. So I could have 18r over 6 minus 3 over 6 equals s. now I can look at this and I notice that 18 and 6 have a common factor. 6 goes into 18 3 times, so I'm left with a 3r, 6 and 3, and my 3/6 can just simply be reduced to 1/2, and that's s. And these two are equivalent. They're actually both the same. If I found a common denominator, this would become 6r here, but either one of these answers would be okay.